Cool. Yeah, sounds good. So yeah, this is a Python package that's been created to extract structured bicycle infrastructure data. So my background, I'm like a freelance data engineer, software developer. I come out of the transportation planning and engineering field, where I worked pretty closely with active transportation. If anyone's familiar with tool design, we did the bicycle network analysis tool with People for Bike. These are some of the tools that I worked with. So I've worked extensively with OSM data, particularly in the active transportation sphere. This is something that always was a tool that we always kind of talked about was, some mechanism to quickly extract out bicycle facility data. And, over the past couple of months, put something together and thought I would just share what I've done here and just get some feedback, maybe get some people energized about it. Because I think it's pretty cool. It really does kind of set up the stage for um, providing a starting point for discussion around these types of things in different fields that some of us work in. So, I'll kind of go over why, the context, the approach to the data structure. So the resulting data structure that comes out of the Python library, methods, and then some of the outputs. So kind of why would you spend your time on something like this that, just the background that I have, the fields that I work in, we primarily we often look for standardized bicycle infrastructure data. And so something like this would be, helpful. There are ongoing interests in this. So the FHWA has the National Bicycle Network project. And then you see these at different levels as well. So states have them where they're looking to develop specific schemas, So this is North Carolina DOT. There's one that I've linked to here in the slides. Ohio is another one that I've helped out with. BMC, which is like the Baltimore MPO area, they've got their schema for bike infrastructure. So you kind of see it at all levels, everything from like the national level at FHWA right down to BMC. And, there are organizations like Overture, which we heard from a few back that also, work with this stuff. So, I think there's a lot of interest in this kind of thing. And, I think given the expertise that I have with, colleagues I've developed over time, the idea of this is just to sort of boil down like the messy data that we get from OSM into sort of like a package that can give us data that can be used right out of the gate, basically, And so, standard processes, they're good for discussion. They help solve gaps, and have provided a couple of useful sort of useful tasks that can come out of something like this. So, bicycle planning, trip modeling, existing conditions, cartography, and there's a lot of people here that I know would be able to think of how else we could use this kind of information. So the context of bicycle data, like this is where it gets messy, and just kind of highlighting the kind of thought about this here. So we have things like lane versus center line geometries, how are we actually representing the nature of the facility within the data that we're working with, the directionality of the roadway itself, sourcing valid data, get things like inconsistent definitions, like what is a bike lane anyway? Is it conventional, buffered, class 3? You can ask other questions kind of along those same lines of like, are shared roads really bicycle infrastructure? So there's different ways of thinking about the context of structured bicycle data. You also get competing priorities as well, routing, cartography, analysis, feasibility. All of these are going to have different sort of conditions that they need to work within when it comes to the data that are needed for the inputs for the analysis. They can be more complex and more simple. But the approach that I took here for this Python library was a functional approach. What can we do a lot with like what data structure can we do a lot with? There's some here that I know that we'll think about routing. Routing can be really complex, and the topology has to be very accurate, and like everything needs to be joined in order for the routing to take place. But other things like cartography, you might not need a very high level or like a very granular, precise data set. So taking a functional approach, the idea here would be to cover like 80% of the work that I would have done and the others that I've worked alongside would have done. So thinking about both sides of the road, but also thinking about the minimum and the maximum of the bicycle infrastructure as well. So, you've got the data you need in order to make a determination on what's on any side of the road, so what's on the left or the right side. If you want to do directionality analyses, keep that information. But also, if you just want to do like a simple analysis where you're looking at, what is the infrastructure that is like the worst infrastructure for a given segment or the best infrastructure for a given segment. The worst might be if you're doing like a level of traffic stress, and the best might be if you're doing like cartography, and you just need to like, consider that, one or the other, basically. That information has been kept within this library here. So if you kind of look to the bottom of the min bike infrastructure, max bike infrastructure, like what this does is it basically, looks at both the left and right side of the road, figures out which one is the best or the worst, and just sort of, fills that attribute at that given location. Um, the the end result really is intended to provide transparency, like from the analytical process, so not trying to create a very simple data set, where you just have the bicycle facility type, but rather all of the information that went into that process. So, that's going to have the F class from OSM. It's going to have the OSM bike facility, so what was tagged within that segment, but then also the transformed variables as well. So really looking to be like functional and also transparent with the information that's stored. And there's some other elements on here that I think are valuable, like the number of lanes, the surface type, whether or not there's a traffic signal, the max speed, whether or not there's a turning lane. These are things that have been helpful within the realm of transportation planning, safety, these kind of things. They can be determinants of, the level of risk, for example, the stress that a bicyclist might experience. So that's all kept in there as well for that functional approach. The way that works is it basically starts with that should be PBF, PBF files, basically the compressed OSM data. There's a process through which it kind of filters out candidate roads. So and that's dynamic based on what the user defines within a file. So it looks at the candidate roads, it filters out the bike infrastructure, so it filters out all the false positives, and then transforms some of the attributes like I had described on the previous slide. The way that this is kept dynamic is through static files that are baked within the library itself. So that's going to be the source of the PBF files. So that's just a simple HTTPS string that you can point to different locations. You can get the latest through GeoFabric, for example, or some other local, whichever you want, really. There's a candidate roads file. So that's based on the highway F class tag. So you can sort of filter out track roads or, steps, these kind of things that you won't want to keep. And then false positives, things where there's a bike lane, but it's tagged as like a sidewalk or, do not ride here or something along those lines. And then there's a sheet that helps translate into common language used to describe bicycle facilities. So you can see at the very bottom on the left-hand side here, we've got, on street, I'll be translated to shared road, and it's got the capitalization, the title text, title format for the name, and then buffer will be changed to the buffer bike lane. So all of that is dynamic. You can change it. It's very easy. And so the idea is it kind of extracts it, transforms it, and then just loads it into a pandas geodata frame and then exports it to a shape file. It's pretty quick. There's probably ways to speed this up, but for chewing through all of California, it's about just under 8 minutes. District of Columbia is extremely quick. The entire US, I ran this recently on late 2024 data, and it took about an hour and 13 minutes. So it's pretty quick overall. Moving on, like the output, yeah, their outputs are pretty nice, actually. We get, coverage for the entire US. It successfully transformed the OSM tags into structured attribute values and uses a logical filtering system for fast delivery. You can kind of see, kind of a back of the napkin length of miles for each facility type that came out. So this is looking at max facility type that I had described earlier. So it's not looking at lane miles, it's looking at centerline miles. That might not be completely, accurate if in any places there's a bicycle facility that's adjacent to the center line of a road. The center line, has a protected bike lane, and then on the other side, there's a shared use path. Some might count that as, maybe just the shared use path, and then, some the center line, but others might separate them out. But the idea was to look at center line miles, the max bicycle facility, and then sum them up. I cross-checked this with a quick Google review, and I think the numbers are kind of all over the place with regard to the number of miles. And but some are really up there, the number of miles up in the 50, 60,000. So to me, I mean, this passes an initial gut check. I know, I think I'm reaching time, but you can see here, so that was the US. You can see San Francisco, Madison, Austin, Texas, Manhattan, the Denver DRCOG area. But that's it. So it's a Python library. It's up at, PYPI. You can see the GitHub repository, and you can reach out to me anytime. Thanks.
Thanks, Daniel. I think that was a great talk for just bringing out some structure, extracting something that is the great thing that is OSM, is that consistency across a wide way. But how do we do that and pull all of that information out? So really appreciated your talk.